we are asked to solve this system of equations. System meaning more than one, and equation, of course, it has the equal sign. So right away, hopefully you can kind of see that these are not comparable or not the same. We have a quadratic, the degree is 2 on this one, the biggest power is 2, and we have a linear equation for this one, the biggest degree on x is 1. So our strategy would be kind of similar no matter what the situations is that they gave us. So we want to set them equal to each other. That's basically our strategy here, the equal values method. Notice that both of these equations are equal to y. So if they're both equal to y, then they're equal to each other. Okay? So I would start off by x squared minus 9x plus 11 equals, since they both equal y, they equal each other. Negative 2x plus 1. Okay, whenever you have a quadratic or a degree of 2, the strategy is a zero product property strategy. So we want to move everything over to one side so it equals 0, and then we try to factor it so that we can use those factors. Each factor has to total 0. Okay, so move everything to one side. I like keeping my x squared positive if possible. It just makes the math a little easier. So I'm going to add 2x to both sides, plus 2x. I'm going to go ahead and do this move all at once, and I'm going to subtract 1, subtract 1. So I'm just moving everything over here to the other side. So x squared didn't change. Negative 9x plus 2x is negative 7x. 11 minus 1 is positive 10. And it equals 0. That's what we wanted. So we're looking for what two numbers multiply to be 10, add to be negative 7. 2 and 5 if they're both negative. So it always kind of looks like this if it factors. The x has to be in front. Since this is a 1, this has to be x, that has to be x. And then negative 2 times negative 5 is 10. Negative 2 plus negative 5 is negative 7. So that links together. And then the zero product property says that each factor has to equal 0. So if this is 0, it zeroes out everything and it's a true statement. If this factor is 0, it zeroes everything out. True statement. So when is x minus 2 equal to 0? When x equals 2. Hopefully you can see that. 2 minus 2 is 0. These aren't too bad yet. I'll go ahead and do this one the long way. If you're not sure what it is, then you just go ahead and set it equal to 0. X minus 5 is equal to 0. When is that true? Well, we solve for x, and x equals 5. Okay, all right. Those are our solutions. That's where it crosses. These two intersect at x equals 2 and x equals 5. Well, these aren't the roots. I don't think they're x-intercepts. They're probably floating around in space somewhere. So we need to find the y values. What's the y that goes with each one of these? So let's start off with x equals 2. Which one is easier to plug x in? Is it the top one or the bottom one? Pick the easier one. Definitely the bottom one's a lot easier to use. We're looking for y here. Y is equal to negative 2x plus 1, and that 2 is going in for x, so we can solve it. Y is equal to negative 2 times 2 plus 1, which is equal to negative 4 plus 1. Y is equal to negative 3. So as a point, we always want to write these answers as a coordinate, as an ordered pair. 2 comma negative 3. That's your x comma y. So that's where they cross at. They intercept at 2, negative 3. And then let's find out what 5 is paired to. Okay, so when x is equal to 5, I'll use my same equation. Y equals negative 2x plus 1. And y is equal to, that 5 is going in for x there. Negative 2 times 5 plus 1. Negative 10 plus 1 is equal to negative 9. That's our y value. Don't forget, we want to write this as an ordered pair, x comma y. So 5 comma negative 9. And then if we wanted to, if this were a test question, I really want to do everything I can to make sure I don't get a test question wrong. That's when it's most valuable. I would take these 2 points and I would plug it into the other equation and see if it's true. So I'd let the -3 be the y, so -3 equals 2 squared minus 9 times 2 plus 11, and see if you get a true statement. Then I would do the same strategy for 5 comma -9. I would look at the other equation that I didn't use to see if it checks out and gives us a true statement.